Hi, my dear students. Let's come together online for the today's session. Let us go through this slide. Hybrid variety of tomato, very much bigger in size, thick skin, but more durable. Now you kindly go through this slide also. This slide is of what? Hybrid variety of brinjal. Popularly, we call it as BT brinjal. What is BT brinjal? Biotechnology brinjal. It is some process is made and this brinjal is made ready. Now concentrate on this slide. This is about hybrid variety of cucumber. Now this one, once again, hybrid varieties of snake beans and papaya. This is snake beans. This is papaya. Please concentrate on the plantation part, tree part, okay, and the number of papaya fruits and how much they are close to the earth or the field where they are planted. All this point you kindly concentrate. Okay. Now I think by seeing these slides, you are very much ready to tell what is the name of the topic today. I think you have made a very good title and your title made is correct. And what is today's title? Today's title is we are going to discuss on hybridization. This word is very popular in biology and this word we use in chemistry also. So I welcome you all for the today's session. Describes the bonding. Therefore, I wrote this small caption. So today's topic of discussion is hybridization, which describes the bonding. What are the other words for hybridization? Crossbreeding, cross, interbreeding, hybridizing, crosses, conjugation, coupling, intermixing. These are the somewhat close to the word hybridization. But now we will apply this hybridization where in chemistry. Okay, all these are general what we understood about the general way of understanding what is hybridization. Now we will pinpoint, we will concentrate in terms of chemistry with respect to chemistry. So from our next discussion onwards, we will discuss keeping in mind hybridization in chemistry. Okay. So what is the definition of hybridization in terms of chemistry? It is defined as the intermixing of the atomic orbitals of same atom having slightly different energies so that they redistribute energy, resulting in the formation of new orbitals of equal energies and identical shape. So hybridization in chemistry means what? It is here. See, till now we understood what is meant by hybridization. It is something about mixing. Okay. Now here in chemistry, what we are mixing? We are mixing atomic orbitals. What atomic orbitals are made up of? Electronic clouds. That means we are mixing the two electronic clouds in a simple way. Okay, therefore, it is the intermixing of atomic orbitals. You see here of same atom, that means carbon's orbitals are mixed, hydrogen orbitals are mixed, boron orbitals are mixed, beryllium orbitals are mixed, nitrogen orbitals are mixed of the same atom, having slightly different energies. Energies are almost same. Slight difference is there of the atomic orbitals energy. So atomic orbitals of almost same energy with a minimum difference. Okay, and those orbitals we are mixing. And why we are mixing? So that energies of all those will redistribute, then they go for the new set of orbitals. Okay, so they redistribute energy, resulting in the formation of new orbitals. See, all those new orbitals are what they have? They have equal energy and identical shape. This is the most important phrase of this definition. Okay, one important phrase is what? Intermixing. Then is next what? Equal energies and identical shape. So once they mix and forms new orbitals, and these new orbitals have the what? Same energy and the same shape. And these new orbitals are called hybrid orbitals, hybrid animals, hybrid seeds. Now in chemistry, hybrid orbitals after the hybridization, after the intermixing. And this phenomenon is called hybridization. So today's topic, now it came into the picture. Now, why do orbitals hybridize? What is the purpose, need, criteria, cause behind the hybridization? Everything in the chemical world ultimately boils down to energy. See, in chemistry, we always speak of energy. Electron has energy, atom has energy. When atoms are combining, that means the energies are combining, mixing, and something new is formed with some other energy. So that means we always speak of what? Energy transformation, redistribution of energy, reorganization of energy, reforming of energy. So all these are called what? Boils down to energy. So we speak in terms of energy. So once again, I am coming to the same point. The entire universe is made up of two entities, matter and energy, and we are in these two only, in different forms. And this is the science, and this is the chemistry. Okay, right. Orbitals hybridize because doing so allows the resultant molecule to be lower energy. Again, same mantra. Why do orbitals hybridize? Because they should go to the least energy state. Okay, so that more stable they go than if the orbitals did not hybridize. Without hybridization, if they go, structure is formed. But with hybridization, they go, that also is formed. But among the two, which one has got least energy? It is the structure which has undergone hybridization that will have least energy. Therefore, orbitals undergo hybridization, then they go to the least energy so that they attain the maximum stability. Okay, this is the purpose of orbitals to undergo hybridization. Now, what is the importance of hybridization in chemistry? Explains molecular structure of both organic and the inorganic compounds. To explain the molecular structure, we have to understand what is meant by hybridization. Results in more stable compounds. When the orbitals undergo hybridization, they will go to the least energy. We have already studied just previous in the previous slide. So that's why they will undergo hybridization, and this is the important second importance of what? Hybridization. Explains what happens to atoms during bonding. Hybridization also explains during bonding what happens exactly. Okay, that means at the microscopic level, at the molecular level, we will understand what is happening. Explains what happens to atomic orbitals when you are going to the molecular level, when you are going to the microscopic level, when you are going to the nano level, pico level, then we will come to know what happens to the atomic orbitals also. explains the bonding and lone pairs of electrons. If single electron is there, it is merging with what type of single electron? What type of bonding is formed? That also explained by the hybridization. So it is also very important point. Explains the formation of sigma and pi bond. Okay. So first sigma bond forms if there is a provision, then lateral overlap, side overlap, that also possibility is there. Then they go for the pi bond. So formation of sigma bond plus possibility for the pi bond also they think. So these are what? These are the importance of what? Hybridization. Therefore, we have to study hybridization chemistry. Now, what are the important conditions for hybridization? The orbitals present in the valence shell of the atom are hybridized. Again, the important point is what? In the valence shell, which are orbitals are there, they undergo hybridization. For example, carbon 1s2, 2s2, 2p2. If you arrange in the form of k element, 1s2, k shell, 2s2, 2p2, L shell. And in the L valence shell, how many orbitals are there? 2s is there and 2p is there. And in the 2p, how many are there? 2px is there, 2py is there, 2pz is there. So all these will undergo hybridization. So atomic orbitals which are there in the valence shell, they undergo hybridization. The orbitals undergo hybridization should have almost equal energy. Naturally, see in the case of carbon, it is 2p2, 2px, 2py, 2pz, same energy. Even if you take 2s also, 2s or 2p belongs to what level? 2s, 2p belongs to the L level, L shell. They have almost same energy. So they undergo hybridization. Promotion of electron is not essential condition prior to hybridization. This is very important. See, in the case of carbon, 1s2, 2s2, 2p2, in 2p2, two unpaired electrons are there. Okay, so they undergo hybridization. If sometimes we require 4 unpaired, that time what we will do? We will promote the 2 electrons of the 2s in the carbon to the empty orbitals of the 2pz. Thereby, one of the 2s will go to the 2pz, going for 4 unpaired. That means we promote, but this is not the essential condition. If required, we will promote, otherwise, no. It is not necessary that only half-filled orbitals participate in hybridization. In some cases, even filled orbitals of valence shell take part in hybridization. These two are complementary. So, what is the condition? First, we believed that only half-filled will undergo. Half-filled for P is what? P3. For D, D5. For F, F7. Only half-filled because unpaired, they undergo hybridization? No. Sometimes fully filled, paired will also undergo hybridization. So till now we discussed the important features, okay, conditions for the hybridization. So in the tomorrow's class we will discuss some other part of hybridization with example. Today we learnt only theory part or the introduction part. Tomorrow actually we will go into the hybridization. So till then, bye and thank you and all.